This is part 2 of the lesson on displacement reactions. So you will need to know what the practical for this actually looks like. How would you use displacement reactions to create an order of reactivity? So this is similar to what we do with the halogens. It's slightly different. We're going to use spotting tiles. We don't need a huge chemical reaction. We could do it in conical flasks, but it's just a waste of materials. I just need to see whether there's a chemical reaction. So I'm looking for a colour change or any kind of bubbling going on. You can see at the bottom there, I've got my liquids, my compounds, magnesium sulfate, copper sulfate, iron sulfate, and zinc sulfate. It doesn't have to be a sulfate, it's just got to be part of the compound. And then I've got all my magnesium ribbons here. There's my copper pieces, my iron powder, and my zinc pieces. So those are the elements that I'm going to be reacting with the compounds. And what I'm looking for, my rules here then, is if there is a reaction, the more reactive one was on its own at the start, and if there's no reaction, the less reactive one was on its own at the start. Okay, so I've drawn out this table. If you want to play along, by all means copy that out very quickly if you want to. If not, just watch as we go through. Now, I appreciate this is not the easiest thing to see on a video, so I have included the link at the end of the video. If you want to watch the YouTube clip, it will make it a little bit easier to see. So, first of all then, zoomed in on my pieces. Here I've got magnesium and I'm reacting it with magnesium sulfate. Well, hopefully magnesium plus magnesium sulfate, guys, you should realise if I've got magnesium, nothing's going to happen. They're both the same. Okay, then I'm going to have copper and magnesium sulfate. So you can play along. Do you think that's going to work? Copper displacing magnesium? I don't think so. And there's no reaction there. Now this is the bit you can't see. It's really difficult to see whether there's bubbles or not. You'll just have to trust me. Here then, iron plus magnesium sulfate. Is iron going to be reactive enough to displace the magnesium? No. And what about zinc? Zinc plus magnesium sulfate. Is zinc more reactive than magnesium? Is it going to be able to displace it? No, it's not. Okay, first line done. Okay, then we move on to our second. You can see that lovely blue copper sulfate then. So here, magnesium plus copper sulfate. So is magnesium reactive enough to displace the copper? Well, I can kind of see there some bubbles. Yes, it is. This one here, I've got copper plus copper sulfate. Well, the same metal, so that's not going to do anything. Next one here, iron plus copper sulfate. If you look carefully, you can see a slight colour change. You can see the blue of the liquid is actually slightly paler, and you would see bubbling there. There is a reaction. And then finally, zinc plus copper sulfate. Again, there's a slight change in the colour of the blue. There would be some bubbles. Yes, there's a reaction. Now you can imagine this is why we do this as a practical rather than as a teacher demo or watching a video. Okay, so the next lot then, we've got magnesium plus iron sulfate. There are some bubbles there, lovely. This one, copper plus iron sulfate. I can't see anything there. Iron plus iron sulfate, well, they're the same, so that's not going to work. And zinc plus iron sulfate, it's really hard to tell, but there should be a couple of bubbles there. There is a reaction. And finally then, this one here, magnesium plus zinc sulfate. There is some bubbling. You can kind of see some specks in there. This one here, copper plus zinc sulfate. Can't see anything happening there. Iron plus zinc sulfate. I can't see anything happening there. And zinc plus zinc sulfate, well, yeah, well, it's the same metal, isn't it? So nothing's going to happen there either. Okay, so now we've got a set of results. What can we do with it? Okay, so here are our results, and more often than not, we're going to be asked to use these results in order to put these metals in order of reactivity. If you want to have a go at that yourself, pause the video. If you don't want to do that, just keep going. So the most common mistake I see is somebody looking at these results going, oh, magnesium sulfate, loads of crosses, no reactions, that must be the most unreactive. And then zinc sulfate's got 3 crosses, iron sulfate's got 2 crosses, and copper sulfate's only got 1 cross. Right, well, that must be the order of reactivity. Well, first of all, it's asking for the metal. So you might say, oh, okay, let's just get rid of the sulfates. But just look at those results. Copper is at the top of this reactivity series. Copper is more reactive than magnesium at the bottom. Does that sound right? Doesn't, does it? So this is where you use your common sense and you use your prior knowledge. If you're answering a question, check yourself. You know that magnesium is more reactive than copper. So this answer must be incorrect. So what I would suggest you do is you remember that you are looking just at the metals. You're not looking at the compounds, you're looking at the metals. These were the ones that were on their own in the beginning. And remember, we keep saying if there was a reaction, the more reactive one was on its own at the start. No reaction, the less reactive one was on its own at the start. So we need to know which metal was on its own. If we look at this and we look across the table rather than down the table, we can see that magnesium has got 3 reactions, more than any other, so it is the most reactive. We can see that zinc has got 2 reactions, it's displaced 2 things, so it's the second most reactive. Iron has managed to displace 1 thing, so it is next. And copper, look at copper, it's not managed to displace anything, has it? And therefore it is the least reactive. Now look at those results. Magnesium is more reactive than copper. Well, I'm hoping you'll be pretty confident with that statement. Zinc and iron, you might be a little bit less sure, but magnesium and copper, you're pretty convinced you're right there. If you've managed to memorize the reactivity series, of course you would know that already. So it's using what you know to inform your answer. Here's another example. So this is one I've just pulled straight out the revision guide, and you can see there's a lot more writing there. It looks a lot more complex. So the first thing I would do before I try to put these in order of reactivity is wherever there's no reaction, I'm going to put a cross, and wherever there is a reaction, I'm going to put a tick. So no reaction, no reaction, no reaction, no reaction. Magnesium sulfate and zinc are formed, so that's something new's been made. I've got a reaction, no reaction. Okay. Now I can see much more clearly what I've got in front of me. I'm going to make sure I'm looking at the correct metals. Am I looking at the ones on their own? Am I looking at the compounds? I'm looking at the ones on their own. Okay, right. Which one's got the most ticks? Magnesium, then zinc, then copper. Does that make sense? Magnesium, zinc, copper. Yes, it does. It follows